This is the mathematics of nature in the sense that if this was a sphere, like a bubble, like a soap bubble, a giant soap bubble, and if I placed a wet straw into this soap bubble and I sucked out the air, which means the sphere is going to collapse, it's going to implode. By sucking out the air, it collapses and actually forms this shape. So the shape that you're seeing now isn't from the imagination, it's actually what nature does when it implodes. The ancient puzzle with three-dimensional shapes is like what shapes can fit inside of a sphere where all the angles are the same, all the faces are the same, and all the lengths are the same. So this is one of the only 5 possible solutions. The ancients saw the five elements as shapes. They understood fire, earth, air and water as specific shapes. But this was the 5th element. This is a dodecahedron. So we're going to talk about the 5 Platonic solids. And what's happened over 2,500 years since Pythagoras was that the whole Pythagorean community they were burnt alive. They were just like a witch hunt. When we talk about sacred geometry, for 2,500 years, we have the memory of fear associated to teaching this ancient knowledge because it's never been allowed to be taught freely, because it's part of your DNA memory and your ascension process. Traditionally, I call this section Platonic solids and Archimedean solids. But when you go to schools and talk about Platonic solids, most people don't really understand the title. So when I go to schools these days, as I teach around Australia, I'm calling this program three-dimensional geometry, as that conjures up the attention that we're going to spend to studying shapes that fit inside of the sphere. The ancients, thousands of years ago, had a fascination for anything that could fit inside of a sphere, and they posed themselves many problems. One of the most ancient problems was what shapes can fit inside of a sphere so that every angle is the same, every face is the same, every line is the same, and every vertex is the same. So they discovered that there's only 5 universal shapes in the universe that can fulfill this puzzle. Of the 5 Platonic solids, the simplest one is known as the tetrahedron. It's a Greek word. Tetra means 4 and hedron means face. So this is a 3-dimensional triangular pyramid that has 4 faces, including the base. All the angles are the same. They have like a 60-degree angle. It has 4 vertices, and it related to the element of fire. They had a fascination for the creation of matter, and they believed that the 4 elements, fire, earth, air and water, were the main constituents, and that there was a 5th element called ether that we'll look at in a minute, which was kind of the substance that imbued through all of matter and creation, and it was the 5th element called dodecahedron. So this one here is tetrahedron. It's based on 60-degree angles, similar to when water crystallizes and turns into snow. The second of the 5 shapes is called octahedron, meaning it has 8 faces. You can see if you look in the center here, it has a square plane in the middle and pyramid-like points above and below. It's quite a common shape that's found in the crystalline kingdom. The most commonly known Platonic solid that fits inside of a sphere is the hexahedron or cube, having 90-degree angles. All the faces are the same, all the angles are 90 degrees, all the corners or vertices touch the sphere, the inner sphere. So that obeys the definition of a Platonic solid. And later on we're going to see, when we have the overhead machine on, we're going to look at the shadows of these three-dimensional shapes to find clues as to what else they represent. For example, I could turn this around at a critical angle so that it looks like a hexagon. So when you're actually looking at a six-sided polygon in 2-dimension, you're really looking at the shadow of a three-dimensional shape. So the next of the 5 Platonic solids is the icosahedron. Icosa means 20, so it's a 20-faced equiangular triangles. Every triangle is the same. This particular one relates to the element of water, whereas the cube related to the earth and the octahedron related to the element of air. You could turn this around and you can observe here, you can see a pentagonal arrangement of a pyramid-like facet where 5 triangles can come together. If we had 6 triangles come together, it would become a flat surface. It wouldn't be 3-dimensional, it would become 2-dimensional. So these shapes that we're looking at show us that triangle, having 3 triangles together make a tetrahedron, 4 triangles together made the octahedron, and 5 triangles together made the icosahedron. And the 5th element that related to a combination of all the other elements, that was a bit like prana, which is the energy that can actually move through matter. Like prana can actually move through walls, and it's a constituent of all the other elements. This was called ether, and it was revered amongst the ancient Pythagoreans and Plato himself. And they called this the 5th element, but they weren't allowed to discuss the information. It was a secret, because it was kind of like one of the codes of the universe. As we will discover later, this is quite an important part of our creation and memory. Dodecahedron is a Greek word. Do means 2. Dec, as you know, in the word decimal means 10. So dodeca means 2 plus 10, which is 12. So this is a 12-sided shape that fits inside of a sphere, and each facet or side is pentagonal. It's like a pentacle. So you can see the 12-sided nature. And I'm very fascinated by this shape because a lot of the secrets that I've learnt in number theory are all based on the number base of 12. Just like we use decimals as in base 10, well, base 12 is the key to galactic measurement. So in my hand here, I've got some die, like dice, the plural of dice. Some dice that have been carved out of some kind of plastic. You can see here you've got the tetrahedron, there's a cube, there's the octahedron. We've also got the icosahedron there with all the 20 numbers written all around it. And there's the 5th one here called the dodecahedron. So these are in the mass consciousness. People are aware of these multi-sided shapes. They haven't really understood what they were, but they're around and people play with them in card games. I also have a set of the 5 Platonic solids carved out of amethyst crystal, amethyst quartz, because each shape stores the memory of a different frequency. They hold a particular range of frequencies. While we're looking at crystals in nature that have the shape of the Platonic solids, here's another particular one called fluorite crystal. It's in beautiful light greens and purples, and a lot of people use this when they're meditating to amplify their consciousness, to guide them in interdimensional travel. People just use them as lucky charms, just because they feel good. They're used in healing and for programming and in setting intentions into them. Like if you want to travel, people program their thoughts or wishes or desires of travel into the crystal. So every time they hold this, it reminds them and amplifies that intention to manifest. Here's another octahedral crystal which I just got at the markets. I was told that it was actually a copper crystal, and some people don't agree that it is. I'm not sure if it's actually copper, but that's what I was told. But it's a very heavy metal like lead, and there was a smaller one here as well. And this little octahedral crystal is almost a perfectly shaped one. So these are naturally formed octahedral crystals as they're found in nature without being cut. This one here obviously has been shaved and polished to be a perfect octahedral crystal, but as I understand, they do appear in nature in this raw form. Here we have an image of Pythagoras, considered to be the father of sacred geometry. According to some of the rare texts I've read about his life, because he never actually wrote anything during his time, according to Manly P. Hall in his book Secret Teachings of All Ages, Pythagoras was born in a small coastal place in Lebanon called Sidon, and due to problems in that country in his first year of life, he moved straight away to Greece. But due to political problems in Greece, they were forced to move to another place in Crotona in northern Italy. Now, prior to Pythagoras setting up his community, he had spent 22 years living with Egyptian priests, and apparently he received all the knowledge of the world orally at that time regarding the mathematics of the planets and the stars and the Fibonacci sequences, or the lost codes that are sort of being revealed at the moment. So he passed on this knowledge as an oral tradition. Then when he moved into Crotona, the academy was also for men and women, and they practiced celibacy, they were vegetarian, there were monks and nuns, and they basically practiced community of goods. All they wanted to do was just focus on nothing but higher learning, which is what they did pretty much of their lifetime. Towards the end of his life, Pythagoras had aroused a lot of political debates, especially regarding the knowledge that they were teaching. And basically the whole community was mass murdered. We believe they were all just burnt alive, pretty much like the witch hunt that happened later on in Europe. So you could imagine now that this world's knowledge of sacred geometry has been lost for 2,500 years. So it exists in our cells as memory. Even when speakers lecture on this subject, a certain emotion comes up because we seem to tap into the memory of being persecuted for teaching this knowledge on the dodecahedron. Most books claim that he lived 500 years before Christ, which makes it 2,500 years ago. We call these shapes the five Platonic solids, but really Plato was like a student of his, but he was about 300 BC. The books that got recorded were known as the Golden Verses, and it's a very hard book to get because you only see fragments of it. But the word philosophy, as most people know, comes from two Greek words, philos, meaning love, and Sophie, the goddess of wisdom. So philosophy was this love of wisdom which they practiced as a community. It's important that when you study the Platonic solids, we need to get an intellectual grasp of the actual mathematical ratios of all the sides. We begin with a cube. We understand that the cube inside the sphere, we give it a basic ratio of 1, 1, 1. Each side of the cube is 1. By calling this the unit cube, we are therefore able to look at the ratios of all the other sides. You'll see here that the other shapes here are based on the square root of 2, and the shapes down here are based on the golden mean ratio. What we're leading up to is to look at an appreciation of the icosa and dodeca, the interplay between icosa dodeca as a key form to time travel because of the phi ratio. But we'll just go through them in order just to get down the fact. I'll explain what the root 2 ratio is on the whiteboard, but when we look at a tetrahedron, you can see that if you tilt it around, it has a shadow view, and it looks like the subdivision of the triangle into 3 equal parts. We can move it around and you can sort of see that there's a kind of another shadow like that. So for each shape, we're going to look at its shadow form. So what I just showed you now was that the tetrahedron as a shadow, it can look like this. We could tilt it around to look like that or like this. We know it has 6 edges, 4 faces, 4 vertices, but the length is root 2. I'll explain that on the whiteboard. Always in sacred geometry, we begin with the basic and most simplest form, and that's often the cube, and we give the side of the cube or a square the measurement of 1. When we draw the main axis in there, called the diagonal, we can determine the length of the hypotenuse by adding the sum of these 2 sides. Most people know that as Pythagoras' theorem, where they say a squared plus b squared equals c squared. For example, if this was 3 and that was 4, that side would be 5. So we know that 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25. What this means is that if we take the square area of this side plus the square area of that side, it would equal the square area of the larger side. Apparently this geometrical theorem was postulated 300 years before Pythagoras. So an Indian scholar called Baudelaire, he actually had written this in text 300 years before Pythagoras. So this is not really Pythagoras' theorem. It was known even before the Indians in Babylon. And we have some rare manuscripts to show that this is ancient knowledge. So when we say, if I wanted to determine the side of this unit square, this diagonal, I would say that 1 squared plus 1 squared equals this side. So if this is 1 and that's 1, then this side here is the square root of 1 squared plus 1 squared. This side plus that side. So that's 1 plus 1 is 2. So we can determine that this side is called the square root of 2, which is about 1.4. So we can see from the tetrahedron that if we have a cube in the sphere, we know that every side is 1, but when we draw the tetrahedron inside the sphere, each length is a bit more than 1, it's about 1.4. So that's what root 2 means there. It's the square root of 2 is 1.414. Now the next shape is the octahedron. These are the shadow forms of the octahedron, and it has 12 edges, 8 faces, 6 vertices, and the length is the reciprocal of the root 2 ratio. So they're kind of like a pair. The cube, as we discussed, everyone knows, has 12 edges, 6 faces, 8 vertices, and its unit length is 1. There's an interesting relationship between the cube and the octahedron, and see how we've got 12 edges here and 12 edges there. We've also got 8 and 6, 6 and 8. There's an interplay between the 6 and the 8 in both of these. What that means is that the interplay or the relationship between the cube and the octahedron is simply that if I was to take the midpoint of the 6 faces, there's 6 faces, and if I was like a spider inside the cube and I could connect the 6 midpoints, I would end up with this shape, which now has 8 faces. It started off with 6 faces, but the shape within it is known as the octahedron, has 8 faces, 8 triangular faces. The opposite of that is true. If I have an octahedron and I mark the 8 midpoints of those triangles, and I'm like a spider inside and I'm weaving a web connecting those 8 midpoints, I would end up with a cube inside of that. So these are called a complementary pair. Another word for that is called duals, D-U-A-L-S. I'll show you that actually as a graphic, just so you understand that. So what we're looking at here is we're looking at the eternal relationship of the Platonic solid duals. So we understand now that the octahedron and the cube are very much related, and there's also another pair that is also related, and that's called the icosahedrodecadual. So I'll explain that now as well. So here's an icosahedron that has 20 triangular faces. If I was to take the midpoint of each of those 20 triangles and I'm inside of that and I connect them, I end up with what's called the dodecahedron. And the complementary nature is the same. If the 12 midpoints create inside of this 20 triangular faces called icosa. So when you put the two together, it's actually a code. The code of the Platonic solid jewel called icosa dodeca is 1220. We start to give these a name now because there's an eternal relationship between icosa dodeca as we go through this material. This is what the Pythagoreans were obsessed about, this ability of the icosahedron and dodeca to forever expand into the universe and to forever contract down into the atom. There's a very critical relationship called the golden mean that we're coming up to, which the other shapes don't display because they have root 2 relationship. The relationship between this and that are based on the mathematics of where the elbow bends. The golden mean ratio permits these shapes to grow in size, expand or to contract. So we can see here that our icosahedron has different shadow views, and I'll show that on the overhead. We can turn this shape around and you can sort of see different facets of it. So we can see that it has 30 edges and 20 faces, whereas its jewel has 20 vertices and 12 faces, the dodecahedron. The symbol here is actually, it's not very clearly printed, but it's a circle with a line going through it. That's called the phi ratio. That means that all these lengths of the icosahedron inside the sphere are based on 1.618. In relationship to the cube that was 1, these distances are 1.618, whereas in the dodecahedron, each length here is 0.618. This 1.618 is known as phi, and in the dodecahedron, this symbol 1 on phi, or the reciprocal of phi, is the relationship of 0.618. One is above unity, 1.618, and one is below 0.618. So you can see the code of 2012 here, and it's reversed as 1220 down in the dodecahedron. While we're looking at this dodecahedron, you can see that it's quite a large model, but there's other shapes within it. There's shapes within shapes, pretty much like the nesting of the Chinese dolls. What we've actually got inside of here are the 5 Platonic solids that I've just discussed are all actually nesting one within the other. If you can look inside, there's some green sticks forming a cube. There's 6 red balls. They make the 6 vertices of the octahedron. And if you look at those 20 white spheres in the center, that's a dodecahedron. It's got 12 pentacle faces. When we stellate the dodecahedron, when we increase the ratio from this distance here to this longer distance there, which is between the yellow balls, when we increase the wavelength of the dodeca to the next larger size based on the phi ratio, we create this yellow shaped here, this icosahedron. If you look at all the yellow shapes now, you can see that we've literally morphed. We've done some sort of alchemy based on a coherent wavelength called the golden mean ratio that has allowed one shape to become another shape without any self-destruction going on. So when I stellate the icosahedron, lo and behold, I have a larger dodecahedron. If you look at these 12 white balls around here, these 20 white balls, we've got 12 pentacle faces. So I've gone from the small dodecahedron to a large dodecahedron. I've literally increased my size. which means if I keep doing this repeatedly, icosa, dodeca, we suddenly found a way of traveling through the dimensions, of changing our size from an atom into a galaxy, and conversely. And this was the secret of the Pythagoreans. They knew this relationship between icosa, dodeca. That was the key. And we have stories in the community of Pythagoras that if anyone divulged this secret of icosa, dodeca, the ability to move through the dimensions, they were literally murdered for releasing this knowledge. It was one of those grand secrets, like the language of light, how the spiral created ABC. So some people who study this knowledge, they're called neophytes, people who are on the path, learning to raise their consciousness by remembering these shapes which are part of their DNA. There's an important group called the Theosophists. So 100 years ago, the people in India and Western Europe, they were obsessed about this shape. The symbol of the Theosophical order was the lesser maze, and the lesser maze is basically what you're really looking at now, is the nesting of the 5 Platonic solid symmetries. It's a way of finding a center and expanding out from the center, going out, but finding a way how to come back in. So this is the grids that allows you not to get trapped or lost in the dimension. So you can have a reference points at the beginning, which is your heart, and then coming back, going on your journey, and then coming back out. Really, the higher level of this esoteric knowledge isn't a pedantic pursuit. It's really about nesting all this geometry into your heart. It's part of our auric hygiene that we can sit inside these sophisticated shapes because they are living entities, and we can tap into these shapes because they're the fractals of the greater picture and the atomic picture. So when I sit inside these shapes, which I do in my own private space, I am able to remember all knowledge. When people talk about, say, the Akashic records, Akasa means spirit, or the spirit library, we are able to journey to any part of our consciousness, which is everywhere, and tap into any knowledge at any time, in the future, in the past, by sort of an understanding that we are connected to the macro and the micro simultaneously. This is the only known model I know that allows us to be connected to everything at the same time. It's like our center is everywhere and our circumference is nowhere. Here's another view of the 5 Platonic solids described by Charles Leadbeater and Besant, who were part of the Theosophical movement 100 years ago in India. And he was just showing you basic shapes in his work on occult chemistry, where we could take the tetrahedron as one building block, which is the basic building block of all atomic structure, and we can interpenetrate that shape to create a compound shape. So when we take